All right, so in this video, we're going to be talking about performing matrix operations on your TI-83-84. Now, I will have to sort of caution that the matrix operations work perfectly beautifully on real numbers, but even if you switch the setting on your calculator to allow for operations on complex numbers, on the main screen, your matrix cannot do operations on complex numbers. So any matrices where you're doing operations on complex numbers, you will have to do those by hand. Fortunately, that is not most of the time. All right, so the matrix menu is typically going to be found in newer calculators by clicking on the button, the second button, and then the X inverse button. So the second button is, of course, the top one on the top row, on the top left, and then the inverse button is like 3 buttons down from there. Now, on some older versions, the matrix button has its own key. So beyond this introduction, I will simply refer to accessing the matrix menu rather than specific keystrokes. Once you get into the matrix menu, the keystrokes should all be the same. Now, when you get into the matrix menu, you're going to get a screen that looks like this if you've never been into it before. You're going to have a list of matrices that are here. If you scroll over to the math menu, then that will have mathematical matrix operations. And if you want to add or edit matrices, you would go over to the edit button. The name screen is just where you would call up a matrix if you're trying to put it on the main screen to do operations on it. Now, if you scroll over to the edit button, edit menu over here, so scroll over twice, then you can enter matrices and enter values for matrices in the calculator. So again, if you enter this for the very first time, you're going to get an entry that looks like this. And the default will be 1 by 1, and the default value for entries that haven't existed before is 0. Now, a 1 by 1 matrix is just a number. So we might want to work, for instance, with solving a system of equations. In this case, we have 2 equations and 2 variables plus the third column for an augment. So this is a 2 by 3 matrix when we convert this system into a matrix. So we're going to enter 2, enter 3, enter in order to enter the dimensions. And then the cursor will fall down to the actual matrix entries. And from here, we can just begin typing. The cursor, when you hit enter, will automatically scroll over to the right as you hit enter. And then when you get to the end of the line, it will scroll down. So here, we would enter 2, enter, and then 3, enter, and then 16, enter, and then -1, enter, and 4, enter, and 10, enter. And then that will have this matrix entered into the calculator. Now you may notice as you scroll through these operations, as you go through from position to position, the subscripts down here indicating where you are located in the matrix will change. So 1, 1 is the position 1, 1 in our matrix, first row, first column. When you get down to the last position, this is the second row, third column. So the position location will say 2, 3. Now your matrix can have entries in it that are more than 1 digit wide, which is why you have a comma here, rather than in traditional smaller matrices where you don't need commas to indicate the difference between 1, 10 and 11, 0 or something like that. So we add the commas in the calculator screen in order to indicate that in case there are any 2-digit dimensions in here, that we could still separate which digit goes in which dimension. Now, once you're done entering all of your values into your matrix, you're going to hit second quit, which is the second button, and then the mode button, it says quit above it. and that'll take you back to the main screen where you can then perform any operation. Now, if I want to change a matrix, I would simply re-enter the matrix menu in the same way, go over to the edit button, and then I would type over any old entries. I can also resize the dimensions of the matrix, and it will adjust those as I enter them and then type over any existing values. Now, some of the operations we can perform on a matrix include things like finding the transpose of a matrix. So to perform this, I'm going to go back to my matrix menu. Again, in most calculators, this is second and then the inverse key. And then I'm going to go to the math menu. And if I want to do the transpose, that is the second function on the screen. So the way that we're going to do this is we're going to go to the matrix menu. From the names menu, I'm going to select A to put that matrix that I want to transpose on the screen. And then I will go back to the matrix menu, go over to math, and then scroll down to select the transpose operation. And then on the screen will appear like this. And then when I press enter again, it will execute the operation and the output will be this. So the transpose operation turns the rows into columns and the columns into rows. So my 2, 3, 16, which used to be my first row, is now my first column. And my negative 1, 4, 10, which used to be my second row, is now my second column. Now, there are other operations in here, like calculating the determinant. That is something that may come up from time to time, again, depending on the class that you're in. There are some other ones, if you keep scrolling down this math menu, such as the row reduced echelon form and things like that, that will be useful, particularly when you're trying to solve a system of equations. But a lot of them we actually won't use. Now, if I want to actually do that solving a system of equations by using my matrix A, again, after I've entered it into the calculator, then I'm going to go to the math menu. And this one I have to enter first before I put the matrix on the screen. So I would first enter my matrix menu, scroll over to math, and then scroll down to the REF function. Now the REF is row echelon form. And then RREF is reduced row echelon form. So actually when I'm solving, I really prefer the RREF because it will give me a matrix with all the answers straightforwardly. But nonetheless, REF will give me a version of the matrix that I can then find the one of the answers in the bottom row and then back solve back. When we're doing this by hand, I would usually solve for the REF form. And then if I'm doing it in the calculator, I want to take advantage of the calculator's ability to do the math faster and go further. But here, I'm going to call up my REF function, and then I'm going to go back to the matrix menu and get the matrix that I want to row reduce, in this case, my A matrix, and then close my parentheses, although the calculator is usually forgiving if you forget that, and then press enter. Now, the row echelon form of the matrix is not unique. It's going to depend on the operations that were performed in the order they were performed in. And so it is important to kind of keep that in mind, that just because you did this row echelon form and the calculator produced a row echelon form, they will not necessarily agree with each other. If you get that last row and you say, okay, this is my final thing, and I plug that back in and hit back solve, you should get the same answer. But for the system, but the matrix that you get will not necessarily be the same as the one that you got from solving it manually. So just keep that in mind as you're solving this. You can use it to check your answer, but you have to do it very carefully in the row echelon form. Now, typically in the TI, they will default by converting everything to decimals, but you can convert these back to fractions that are consistent with maybe the expectations of your instructors by going, after you've gotten your row echelon form, going to the math menu and then hitting enter, which is the convert to fraction button, and then hit enter again, and it will actually convert your matrix entries to fraction form so that you can give exact values instead of these decimal approximations. Now, if you run the RREF form, the reduced echelon form, that is unique. And so it will also just list your solutions. This form of the matrix does not depend on the order that you apply them in. And so again, we're going to go to the matrix menu. We're going to go over to the math menu. Within that, scroll down to the RREF. Although personally, I find it easier to scroll up from the bottom of the list, but whatever. Find your RREF function, then go back to matrix, call up your A matrix. And then when you run that, again, we can get these converted to fractions by using math convert to fractions key. And we will get the unique solutions for each of our variables. Because remember, this matrix means x equals this and y equals that, or x1 equals this and x2 equals that. Now, some more recent calculator models like the 84 will have some features that allow you to set the output to fractions all the time. If you have those newer 84 calculators, check the mode menu for this option. But I don't think it's turned on by default. And then our third example, we're going to calculate the determinant of the coefficient matrix for the system above. This is one of those other operations that we do sometimes in our calculator. So for example, if we're going to go back into our matrix menu, and we're going to edit our matrix. We have to make it 2 by 2. Now this will automatically drop the augment. And since we're going to use the same coefficient matrix we had before, we don't have to change any of the specific entries. We just dropped off that third column. But you can re-enter the entries if you need to. And then in order to access the determinant, we'll then go back to the matrix menu, scroll over to math. The determinant is the first function on the screen, so call that up. And then go back to the matrix menu, select the matrix you want to calculate the determinant for, and then when you press enter, this will calculate 11. Remember, the determinant is the diagonal entries minus the off-diagonal entries for a 2 by 2. So this would be 8 minus a -3, which would give me 11. Now, if the determinant is not 0, we can also find inverses of our matrix. And the inverse key is just on the regular calculator screen. So here I'm going to go to the matrix menu to call up my A matrix. Again, it has to be square. This won't work. Same thing for determinants. I'm going to call up my A matrix, and then I'm just going to hit that X inverse key, and that will calculate the inverse of my matrix. And again, I can go to math fraction and convert it into fraction form. And if you are familiar with the formula for a 2 by 2 matrix inverse, you recall there is a determinant fraction outside that matrix, and that's why we end up with our fractions being all divided by 11, because our determinant was 11. Now, if I were to create a matrix that had a 0 determinant, for instance, so if I fill in my top row of my matrix with all zeros, then the determinant of this matrix will be 0. And if I try to take the inverse of it, then I'm going to get an error called the singular matrix error. This just means that the determinant is 0 and there is no inverse. If I try to take an inverse of a non-square matrix, so if I had left my dimensions as 2 by 3, If I try to take the inverse of that, I will get a different error. In this case, an invalid dimension error. And that will just be an indication that my matrix isn't square, and I can only take the inverse of a square matrix. I'll get a similar error if I try to take the determinant of a non-square matrix. It'll say invalid dimensions. If I try to multiply two matrices together that don't have compatible dimensions, I will get a similar error. Now, I can also perform matrix operations inside my calculator. So for this example, I'm going to enter 4 matrices into my calculator. So my A matrix, I'm going to re-enter my 2 by 3 matrix that I had originally. My B matrix, I'm now going to enter a 3 by 2 matrix with these components. Again, when you go into the menu, matrix menu again, you'll go over to edit. You'll scroll down to B, you'll hit enter. You'll first enter the dimensions, which will be 3 by 2, and then you'll enter the entries across the rows. So 0, enter, 9, enter, 1, enter, 2, enter, -3, enter, 5, enter, etc. We'll also enter a C matrix, which is a 2 by 2. So 2 by 2 dimensions, and the entries 1, 0, 5, -4. And then similarly, our D matrix will also be 2 by 2, but with entries 7, 3, -2, and 8. Now, if I want to perform matrix multiplication on A and B, I can, because the dimensions are compatible. This is a 2 by 3, and this is a 3 by 2. The inner dimensions agree. And so what I'll do is I'll go to my matrix menu. I'll call up the A matrix from that names menu. I'll hit multiplication key times, and then I'll call up my B matrix and from my matrix menu, and I'll just hit enter, and it will do the matrix calculations for me, and it will output the value. Again, when you're learning how to do these operations, you should practice doing them by hand, but this is a great way to verify that you haven't made any arithmetic mistakes. When you are calculating matrices, you can also do, for instance, addition and scalar multiplication. So for matrices that have compatible sizes. So if I want to add C to 3 times D matrix, they're both 2 by 2, so they can be added component by component. And again, I can pull up my C from my matrix menu, +3, and then call up my D matrix from my matrix menu. And when I hit enter, it will perform those operations and give me the result back on the screen. I can also raise square matrices to powers. Non-square matrices will give you a dimension error, but square matrices, you're basically multiplying C by C. And so the dimensions are compatible, and you can do C squared, and it will again output the value. You could do C cubed or whatever other dimensions that you wanted. Now, sometimes we can combine multiple operations and sometimes we can't. Sometimes the calculator will get a little confused, and you do have to add extra sets of parentheses in order to make sure that the calculator is performing operations in the order that you expect it to. So there is a formula called the normal equation in linear algebra that we use to solve for regression problems. That's the linear algebra version of solving for linear regression and statistics. And the formula has a lot of stuff going on. There's a coefficient matrix. We have to transpose it and then multiply by the original matrix. And then after we do that multiplication, then we have to invert the result because that will be a square matrix. And then once we invert it, we then have to multiply it by the transpose of our original matrix again. And if we are not careful about the way these operations are being performed, then sometimes the calculator will get confused. So with this particular notation, I have the parentheses here around my A transpose A operation to make sure that though that multiplication is done before I try to do the inverse, because it's this multiplication that ensures that the matrix is square. But then if I'm getting an error for the rest of this, it may be because the calculator doesn't understand that I have to do the transpose of A before I multiply that inverse. And the dimensions may not match if it tries to multiply A first and then do the transpose. So you may have to enter different sets of parentheses when you get a dimension. So this formula has to work, but it's just a matter of communicating with the calculator to make sure that it is performing the operations in the order that you intend it to. So you may have to put an extra set of parentheses around your A transpose in order to, again, communicate with your calculator that you need to do the transpose on A here before you multiply it with your inverse. I have seen it in different calculators both work and not work without that extra set of parentheses. But if you find that performing multiple operations is getting you errors when it should be working, adding those extra sets of parentheses just help to communicate to the calculator, like, this is what I'm expecting you to do. And it will help clear up any ambiguity. Now, there are some other useful operations in the calculator in case you need to perform other operations. There is an identity operator in here where you can create a matrix that has a particular shape. So rather than enter all 16 entries manually, you can simply use the identity function from the math menu inside the matrix, the math submenu inside the matrix menu. And specify simply the size of the identity matrix, and then it will output that identity matrix to the screen. So again, sometimes there are useful operations for that. Creating an identity matrix of a certain size is often useful in calculating certain types of problems, for instance, for Markov chains, which we'll cover in another video. Now, just as an aside, if you have a TI-89 or a my beautiful TI-92 from way back in the day, most of these commands also exist in the TI-89, but the difference will be in entering matrices into the calculator. So matrices in the TI-89 and the 92, if you have one, are usually not named. But you can work with unnamed vectors. So the way that you would enter a matrix into the TI-89, for instance, would be to use a square bracket, which you can get from this calculator screen. And then you would enter the entries in, like, say, the top row, 2, 3, 16, separated by commas. When you get to the end of the row, enter a semicolon, and then enter the entries in row 2, also separated by commas, -1, 4, 10. And then when you're done with the matrix, close the square bracket. And then you can usually, again, call up either by typing or by searching through a menu for all of the operations that we've talked about. You can do the multiplication, you can add and subtract, you can find RREF forms of them, and so on. So all of those operations are still in there. On the 92, you have a full keyboard, so you can just type in RREF and you don't have to look through the menu. In the 89, there is still a menu of operations that you would have to find where those functions are. So beyond that, though, I would recommend checking your operator's manual for more information on how to find that matrix, that list of linear algebra operators. Often they're also in the catalog menu. So on all these TI calculators, there is a list of just all the functions that are in the calculator in an entry called the catalog. And if you can go through that, you can always find it. It's maybe not the most efficient way, but when you don't know what menu it's buried in, that usually works if nothing else works.